Good morning students. In this video we will discuss about the escape velocity. We know that any object thrown upward fall down after some time. This is due to the gravitational force. The object moves upward due to the initial velocity u, and it is moved upward due to gravitational force. Its velocity decreases and becomes zero at a height, and it falls down back due to the gravitational force. Whenever we have an object and we are throwing it upward, it travels some height and afterwards it falls down. This happens because whenever we are throwing an object upward, it has an initial velocity. Due to the initial velocity, it is able to move upward. After traveling a particular time, its velocity becomes zero. And here, the only force that is acting on the body is the gravitational acceleration. Due to this force, what happens is, after reaching a particular height, the object starts moving downwards. And this happens to any object which is thrown from the earth. Thus, higher the initial velocity, the larger is the height reached by the ball. Also, we know that value of g decreases as we go higher. That is, the pulling down force decreases. What happens here? Whenever I have an object, if the initial velocity is quite high, the amount of distance it can travel will be larger. After traveling, when the final velocity becomes zero, from that point it starts falling downwards. Suppose we have given an object such a velocity that it reaches a height, that is, by the time it reaches zero, the value of g is also zero. Then the object can come back to earth. I repeat. If we are giving an object such a high velocity that it reaches a height that by the time its velocity reaches zero, the value of g is also decreased to zero. Then the object cannot come back to the earth. I am throwing an object upward. I am giving the initial velocity very high, that when it is moving upward, its velocity is decreasing. So the v is becoming zero. But it is reaching such a height that at this height the g is also zero. So the gravitational acceleration at this point is not having any impact on this object. So at this case, what happens? The object is not falling down. It is not falling downwards because there is no gravitational force. The force that is pulling it downward becomes zero. So it is not having any effect on it. So the gravitational acceleration becomes zero. Escape velocity of a planet is the minimum velocity given to an object on that planet, due to which it will just escape the planet and will not come back. So if I am giving such a velocity that it is reaching a point where its final velocity is zero, at that point the gravitational acceleration also zero. So the velocity which is helping the object to attain that point is called as the escape velocity. Escape velocity is the minimum velocity, that is the velocity required for an object to reach that point where the gravitational acceleration becoming zero. To derive the escape velocity of Earth, we can take m as the mass of the object, capital ME as the mass of the Earth, and VE as the escape velocity. The law of conservation is used to explain this. So according to that, the initial kinetic energy plus initial potential energy is equal to the final kinetic energy plus final potential energy. At an infinite distance from the earth, the kinetic energy and potential energy becomes zero. So when we are taking a point which is infinite, at infinite distance, the final potential energy and kinetic energy, the final potential energy and kinetic energy becomes 0. So here, according to the law of conservation, the kinetic energy initial plus the potential energy initial is equivalent to kinetic energy final plus the potential energy final. And as we are talking about an infinite distance, this becomes 0. So, the kinetic energy initial plus kinetic potential energy initial is equal to 0. We know that kinetic energy can be given as half mve square and potential energy is given as gm m by r, and that is equal to 0. Half mv square is equal to gm m by r. So ve square is equal to, so we can cancel this, sorry, half m ve square is equal to g capital M small m by r. So we can cancel both m here, and ve square is equal to 2 gm by r. ve is equivalent to under root of 2 gm by r. If we are multiplying the left hand side by r in the numerator and denominator, it becomes under root of gm upon r into capital R upon r, which is equivalent to ve is equal to under root of 2 r g m r square. G is equivalent to gm upon r square. Therefore, ve becomes under root of 2rg. We know the values of r and g, and that is under root of 2 into 6.4 into 10 raised to 6 into 9.8. When we solve this, we get 11.2 kilometers per second. So if our initial for the escape velocity of the earth is 11.2 kilometers per second.